So yeah, make S subjects formula. Yeah, so that is a raised to power s raised to power s plus b s raised to power s plus c is equals to r. So how can we make s subjects formula? Yeah, to start, I can say let s raised to power s be equals to p. So if s raised to power s equals p, the equation becomes, and the function becomes a raised to power p plus bp plus c is equals to r. So because this s raised power s is now p, so the function will becomes this. So from here I need to find p first, and remember s raised to power s is p and we are looking for x. So let me find p first. So from here I can find p. So this is the same thing as a raised to power p is equals to r minus c minus bp. So take these two to the other side, r minus c minus bp. So this is the same thing as a raised to power p is equals to, can take p and b out, yeah. So open bracket, so this will be r over b minus c over b minus p. Remember I said if you say anything is common, so I remove the coefficient of p there, so I have to divide everything here by that b, so that if I multiply again, b times this I'll get this, times this I'll get this, so I'll get everything back like that. So the next thing now, I can say this is the same thing as a p divided by b is equals to r over b minus c over b minus p. So I'm trying to use Lambert's W function because to make p subject formula here is not ordinary. So now I can also say this is the same thing as 1 over b is equals to 1 over a raised to power minus p, a raised to power p brackets, because if I cross multiply, this a raised to power p will go back to that place. So or you multiply both sides by 1 over a raised to power p, here too 1 over a raised to power p, so you can see how it will cancel out. So you can say multiply both sides by 1 over a raised to power p like that. So now 1 over a raised to power p r over b minus c over b minus p. Let me show that part. So multiply both sides by 1 over a raised to power p, so you can see, so 1 over a raised to power p. Also this side to multiply by 1 over a raised to power p, so that this will cancel out, remain 1. So we have 1 over b equals 1 over a raised to power p, so like that. So we are looking for p. So the next thing I can do here, I can say this is the same thing as 1, I can change this 1 over, I can change it to a raised to power minus p. So r over b minus c over b minus p. is equals to 1 over b, as in 1 over b there. So this is now 1 a raised to power minus p. So from here I can multiply both sides by a raised to power this. So multiply both sides, or multiply through, by a raised to power r over b minus c over b minus p. So multiply through by, no, remove p, multiply through by this, both sides. So we are going to get a raised to power minus p times a raised to power r over b minus c over b, then brackets r over b minus c over b minus p. So it's equals to 1 over b times a raised to power r over b minus c over b. So I'm multiplying this by both sides. So this will becomes a raised to power r over b minus c over b minus p, as in these two. Know the base are equal. If the base are equal, you add the powers. So r over b minus c over b minus p, brackets r over b minus c over b minus p is equals to 1 over b times a raised to power LCM here is b. So this is r minus c, like that. So I will apply exponential. Remember, e raised to power ln s is equals to x. So that means I can apply it here. This is the same thing as e raised to power ln a raised to power r over b minus c over b minus p, because this is still the same thing as this. Then r over b minus c over b minus p. So it's equals to 1 over b times a raised to power r minus c divided by b. So it's equals to this. So this can go to the back of this ln a. So I can have r over b minus c over b minus p. So I'm writing this e raised to power r over b minus c over b minus p ln a. So is equals to 1 over b times a raised to power r minus c divided by b. So multiply through by ln a. So multiply through by ln a. So multiply through by ln a. This will be r over b minus c over b minus p ln a e raised to power R over B minus C over B minus P ln A is equals to 1 over B times A raised to power R minus C over B ln A. So that is all this one to multiply by ln A. So we can use the definition of Lambert now, because I've achieved my aim here. So let me write this. It equals 1 over B times 1 over B times A raised to power R minus C over B ln A. So that's what I want to write here. So it's equals to, because of space, so it's equals to this. Now I've achieved definition of Lambert here, because f of s is equals to s e raised to power s. So if you look at what we have here, this ln A is the same thing as this. So that means I can change it to function of this. So that means I have f of R over B minus C over B minus P ln A. So function of this, because this will give us this expression, because f of s is equals to s e raised to power s, like that. So this is the same thing as is equals to all this, so I have not changed anything here. So still equals to this ln A. So equals to this. So multiply both sides by, take note, because of space, that's why I'm bringing it down. So it's equals to this. Take the product log of both sides. So that will be W F R over B, that is W is product log C over B minus P ln A will be equals to W ln A, that is over B, times A raised to power R minus C over B, like that. So take the product law. So W and F will cancel out. So I will have, if W and S and F cancel out, I will have R over B minus C over B minus P ln A will be equals to W ln A over B times A raised to power R minus C over B, like that. So this is the same thing as R over B minus C over B minus P is equals to W ln A over B times A raised to power R minus C divided by B, everything over ln A, like that. So P is equals to, so take this P to the other side. So it's equals to R over B minus C over B minus W ln A over B times A raised to power R minus C divided by B, everything divided by ln A. So this is our P now. So I found P like this. But remember that S raised to power S is equals to P from beginning. So S raised to power S is P. So I'll save this P. So this is our P. Let me remove this one. Yeah. So this is our P. We are going to record this P. So but now we know that S raised to power S is equals to P from beginning. That is, we represent S raised to power S to be P. So how can we find S now? So to find S, so I'll show the workings here. So from here, let's find S. So we are still going to use the Lambert W function to find S here. So I have a derivative for this S raised to power S direct, but for better understanding of the principle, so let's make S subjects formula. Excuse me. So let's start. So our aim here is also to change everything to S e raised to power S. So that is the definition of Lambert. So and anytime you are looking for S or you are making S subject formula, that is what you will be working towards, to make S subject formula. So now the first step we are going to do, because this function is this, so multiply both powers by 1 over S. That is, I have to remove that S. So first step, multiply both powers by 1 over S. So if you are jotting it down, you can write all the process, but for now I'm not writing the process, so make sure you jot. Multiply both powers by 1 over S. That would be like S times 1 over S, as in like this, is equals to P raised to power 1 over S, so that this S will cancel out. So S will be equals to P raised to power 1 over X, like that. So apply ln to this side, the E to this side. So this will becomes S is equals to E raised to power ln P raised to power 1 over X, like that. So S will be equals to E raised to power 1 over S ln P. Remember, this expression is the same thing as this, because E raised to power ln S is equals to S, since ln is equals to log S to base E, and I've explained this in the other video. So now S is 1 over S ln P. So the next thing is you can multiply both sides by multiply both sides by lim p divided by x. So that means this place will be lim p over s. So we are multiplying both sides by lim p divided by s. So s will cancel out. So I'll have lim p equals lim p divided by s e raised to power lim p divided by s from there. So from here now I've achieved s e raised to power s, because the number the expression here is the same thing as the expression here. So far I've achieved that. So this is now a function of lim p over x. So all this now is a function of lim p over s, because function of s is equals to s e raised to power x, like that. So everything is equals to lim p. So take the product log of both sides. So wf lim p over s is equals to w lim p. So w and f are inverse of each other, so it will cancel out. So it remain lim p over s is equals to w lim p over 1 cross multiply ws lim p is equals to lim p. So s is equals to lim p divided by w lim p. So this w lim p is inside. Not that this will cancel, or it cannot cancel out. So you can't cancel it out. So that means we have known our s now. Lim p over w lim p. So s is equals to lim p divided by w, like this, lim p, if I write it this way. So not that this will cancel there, it cannot cancel. This is like saying 2 divided by, this is the same thing as saying 2 divided by w2. So we cannot say 2 cancel 2, so you can't cancel out. So that is it. Because w is a function, which is the Lambert the w function, in which we can evaluate in your calculator. So now that we know s and this is our p, this expression is our p, so this is the value of s. We have made s subjects formula where p is this. So if you want to make the expression complex, so that is when you say lim. Now to write p, so you are going to write all this expression. Let me just cut it straight. So since this is p, this is p, just bring it here, as in like that. You know s is lim p, abi, and we have known p already. This is p, so s is all this I want to, because of space, I'm through already, but just to, this our p, lim, all this. So this is lim p, this is lim p, and all this is p. So lim p divided by w lim p. S S is equals to no space. So S is equals to ln P divided by W, as in W ln P. So this ln P. That is if I want to bring everything at once. So bring it down again. Divided by W ln P. So I'll have my W here. W ln P. So this is the value of X. So we have solved. So we have make S subjects formula like this. Or you just stop here and say where P is this anyhow. So I just replace P back. So I've make S subjects formula.